Okay, so today begins a new segment. We're going to be studying and learning all about the coding language called Python. So to start us off, we'll talk about what we're going to do this week, and then give you some introduction to Python today. So again, we didn't have any school yesterday. Today we'll do mainly a lecture, and then we'll be interactively working on some exercises within Code Sculptor. And then finally, you'll have a lab towards the end of the week. So we'll be doing a lot of hands-on work, but today is more exposing you to what we're going to be playing around with in Python. So basics of Python and how we're going to manage files, etc. for this class, for this segment of the class. Python is a computer programming language. It is both object-oriented and interpreted. Interpreted as opposed to being a compiled language, which takes code and basically rewrites it into a sort of a machine language type coding. That's not what this type of software does. So many other really valuable programs are also interpreted, but this is a pretty easy one to learn. We're going to be using version 2.7. There is 3.0 out as well, but 2.7 is really stable, so we'll be working with 2.7. Okay. When we are playing around with Python, white space is really important. So white space means we want to be creating code, and we do that within Python by indenting our code. And by indenting our code, we're creating little blocks. And so if we've defined a function, we'll talk about functions later, this would be a comment, it has a little pound sign. Then we indent by 4 spaces to come up with an if statement. So that we're blocking off the code by having these indents. So then if this is true, and then we indent 4 statements, then it's going to print this is the second block. Else if it's false, it's also going to print this is the second block. So by indenting, we're telling our code what to look for the next step. So then return is part of the original first block. So the idea is indenting is really important in Python. You can indent by doing space, 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 so 4 spaces, or by tabbing. If you are writing code in different types of text editors, tabs can be problematic. In the interface that we're going to be using, it's very forgiving, so it should not be an issue. If you get into some advanced Python, then it might be something you need to worry about. Okay, Python, it turns out, is resident on many Mac computers. So including yours if you are here in the Miramani Mac lab. And you can get to Python using terminal mode. So terminal mode is kind of cool. I'm going to bring it up terminal mode. And the way you, whoops, sorry, lost you there. The way you get terminal mode, you go Command space, and you get the spotlight search, and I'll type in terminal. And up it comes. And now I've made my terminal look really nice. I have a blue background. You can play around with the windows and the color. So this is now in terminal mode. Once I'm in terminal mode, you seem like kind of a hacker when you're in this. A lot of people are really comfortable working in terminal as opposed to the Windows interface. I can type in Python. And there I am. I am now in Python. And so I encourage you to do that, to go on right now, pause this video, go find terminal, get it open, and then type in Python, and you should get this little greater than, greater than, greater than prompt, which lets you know that you are in Python. So once you get there, then restart this video and we'll continue. Okay, so assume you're back. I want you to type in each of these things and just kind of see what happens. I'm going to do it while you're doing it, so I'll type in name equals, and I put quotes, Steph Curry. Hit return, nothing happens. But I put print name, and it prints out Steph Curry. Let's try some little simple operations. I'm going to say 3 plus 5 gives me 8. Let's try 3.0 plus 5.0 and see if I get the same answer. Do I still get 8? This time I get 8.0. That's interesting. We're going to talk about that more today. Let's do 5 and then percent sign and then 3. If you remember from scratch, percent sign means modulo, which means find the remainder. 5 divided by 3 gives you what remainder? I get remainder 2. So Python could be used as kind of a simple little calculator if you want to run some numbers. Let's try this. Type, and then put in parentheses 3. Okay, what type of an object is the number 3 in Python? And it comes back and it tells you that's a type of int for integer. We're going to talk about integers really soon. All right, let's write in one more. Let's write descriptor equals stud muffin. Okay, now I'm going to go print name. Remember, way back up here at the top here, I defined name with Steph Curry. And now I'm going to say print name, comma, descriptor. And see what I get. Steph Curry, stud muffin. So there it is. So print name, what I just ended up doing is printing 2 variables. So if you want to exit terminal, this is fun to play around with, and I want you to know that it's here on your computer. We're not going to actually be coding using the terminal mode, although you could do it. We're going to use a more user-friendly interface in order to do our coding. So to get out of Python within terminal mode, you go Control D. And now I'm back into regular terminal. I'm just going to close out that window. Okay, so fun times playing around with terminal. So we want to develop our coding in a more friendly development environment. Within terminal, you could create little text files and you save them as a file called myprogram.py for Python, and you could run that from terminal. And a lot of coders do that. If they want to do a quick and dirty little code to figure something out or to find some information, they'll make a little text file and run it in terminal and see what kind of results they get if they want to do a little test or something. So that's a really common way of using it. But for the case of our trying to learn to code, we want a more friendly environment. And so we want an environment that has a frame, which is like a text editing space where we can type in code. And then we want a window that is going to display the output from our code so we can test to see if our code is working correctly. It would be ideal if our interface, our environment, had what's called an API, or an application program interface, which is just a fancy word for saying it has documentation or help that you can access. And finally, what's wonderful is you have a GUI, which stands for Graphic User Interface. In other words, could you build some cool graphics that move around the page and play games and stuff like that? To find an environment that is fun to code, we call this an IDE, or Integrated Coding Environment. No, that's not right. It's an integrated development. Wow, sorry. Development environment. Yeah, IDE, duh. All right, moving on. So the one we're going to use is called Code Sculptor. And it's at codesculptor.org. So I encourage you right now to pause the video and go and get on your browser and access codesculptor.org. You can type it in www.codesculptor.org and see what it looks like. Okay, and then come back here and we'll give you a little tutorial of what you see. Okay, so hopefully you're back. And in your window, I want to point out some features of what the Code Sculptor development environment looks like. This is called the frame. This is where we're going to be typing on all of our code. Notice it's really nice. It has kind of color coding. It kind of helps you to know that you're setting up your code correctly, so it looks good, so it's formatted correctly, so the syntax errors will be minimized. This is your window, and this is where you're going to get the output when you run your code. Now, in order to run your code, you're going to push this little play button up here. You push that little play button, that's going to execute the code. There's right here is a little disk button. That's where you're going to save your code, which is really good. When you do that, it creates your code, it saves it, and gives you a fresh URL. So try it, play around with that. We'll have you do that for part of an assignment in a minute. Downloading and uploading your code, you can actually download your code and save it on your computer if you want as a text file, or you could upload code into this window from a text file you've saved somewhere else. Maybe you wrote Python code on another format and you want to bring it in here, you can do that. We won't be using that, but it is available to you. And then let's say you're running your code and it's in some sort of infinite loop. You want to click restart, you click that little button, it's going to restart. It's sort of like the stop button in Scratch. Okay, and then over here, Docs has all kinds of great documentation on Python. And this is documentation especially as Python that works with this particular developmental environment. There's lots and lots of really good documentation on the web. If you just type in Google Python and whatever issue you have, it'll bring you to documentation that can explain it to you. So that's what developers do. When they get stuck, they just go to Google and look up how sources of help. And then over here, Viz Mode is a debugger. We may or may not use this, but it's kind of cool. It's part of this interface. Mostly you're going to be debugging just by figuring out what's going on, but that's for pretty high-level programs. Okay, so that's kind of the environment we're going to be working in. Why Code Sculptor? It's just one that we chose and we find it really friendly. There are lots and lots of IDEs out there for Python. This one was built by Rice University. We like it because it has the helper documentation. It's really forgiving with the white space, which is that indenting. The color coding makes it more readable. But we really like the way when you save a file on your browser, it creates a unique URL for you. So when you go to save a file, it says user 30 and then all this little text .py. And that would be like the first time you save a file, that's what you're going to get. And then if you go and you hit that little disk icon again, it's going to give you .1.python, and then you save it again, .2.python. So that's really useful because as you are working on code and you save it, each of the former URLs that you saved are still accessible. You could just, working in your browser, change the 2 to a 1, and it will take you back to that previous version that you had saved. So that's a really good way of protecting your work. It's not like Scratch where you have autosave. You're not going to have any of those nightmares. So that's a wonderful thing. Okay, so you can always go back to earlier versions if you want. Okay, and one of the things that's really important in Python is to add comments to your code because reading code is really difficult to do. So you add comments to describe basically everything that happens. In talking to some coders, they say the comments are more important than the code itself, especially to an outside reader. So commenting your code is really critical. And it just helps you keep track of what you're doing as you get longer and more complicated codes. Okay, so in order to comment, you put a little hashtag or a pound sign. And then you can write anything you write after that will be interpreted as comments and not actual commands within Python. You can put a comment on its own line, so on a separate line, or if you have it, you could just add it, define click. This would be some sort of a function definition. You could put it on the same line and just have your comments go right after the hashtag. So either way is fine. You can also have like triple quotes for multi-length, super long comments if you're running a paragraph. But most people just put a little pound sign at the beginning and that works just as well. All right, why Python? Well, Python is a great language to kind of start off. First of all, it's really, really powerful, and it's used everywhere. They had coursework at Google to teach their employees to use Python so they can interact with their computers efficiently. So it is very powerful and very much in use. It's also really easy to read. So this is an example of the same code that you would run in Java versus in Python. In Java, you have to have curly brackets to set apart blocks of code, and in Python, you just use the indentation. So it's cleaner, neater. So we're going to be learning basic coding techniques using a language that is fairly simple to read and to learn. But the basic concepts of coding are similar for either language. All right, so let's get into object types within Python. We have several different object types. We have integers, we have floats. Float is another word for floating point. It's short for floating point, which means like a real number, a decimal type number. String is, you've seen strings before, is an object that has text in it. Boolean is a true or false. We can create lists and we can create functions and all kinds of cool things. So if you type these into your Code Sculptor editor window, if you print type 3, it's going to tell you what type of object that is. So 3 is an integer, so it's going to come out with the output class integer. So this is the class of this type of number. So this is an integer type of 3.2. That would be a float, which is like a decimal. Hello, and we always have text within a quote. It could be either single quote, or double quote, double quote. That would be a string, so it says class str for string. Print type true, that's a Boolean. And then this, we have a bracket 1, comma 2, comma 3, that's a list. And you could have a function. So these are sort of the key ideas, the key types that we'll have within Python, and we'll be getting very, very familiar with all of those. Okay, so here is your introductory assignment. Pause the video and do each of these tasks. It won't take you very long. It's more of a getting used to the methods of saving code and putting it into a portfolio. So here's what I'm going to do. Just quickly, I'll walk you through it, and then you can go ahead and do it. So I want you to go to codesculptor.org to the developer interface. Bookmark the site so that you're going to access it quickly along with your course calendar, because you're going to be hitting it all the time. So see this text I've created right here? I want you to go ahead and type in this text. So delete what comes up when you have codesculptor.org. Delete that and replace it with this. Have some comments with your name and today's date, and then all I want you to say is print hello world. Okay, that's your entire program for your very first Python code. Okay, once you have that typed out, go ahead and hit the play button, which is this one right here. And once you've played it and you see what happens, then save your code by hitting the disk button. Okay, and that's going to generate a unique URL. And I want you to copy that URL, and I want you to save it into your new Python portfolio. Okay, so you have to create your portfolio. I've given you a template. Its template is here. It's also on your course calendar. I put you a link to the template. So click on that link and create a new portfolio. Now, it's not pre-built the way it was for Scratch, so you're going to be creating it as you go. I just need to have a place for you to store all of your work, because you're going to want to go back and look at files that you created before to remember how you did things. So find that template and create it. You're going to make a file, because you're not going to use a template. You're going to make your own version of the portfolio, and then you're going to save it. Then go ahead and paste in the URL of this first program into your portfolio. Save your portfolio and bookmark it, because you're going to access it repeatedly. And then once you're all done, share this URL for your portfolio. Remember how to do the share button up here? You click share and then you do copy link. Make sure you do that when you're sharing your portfolio with me. Okay, so pause the video now and go ahead and complete those tasks, and then come back and we will keep going. Okay, hopefully you're back. Little introduction now on Python expressions. So if we take objects, we talked about strings and integers and floats, and we take operators like plus and minus and other cool operators, and we combine them, we can form what are called expressions. So here are some simple definitions. Int is an integer. This is similar to an integer value, with the exception there is an upper bound. So for both integer and floats, they can't be infinitely large numbers. There's only so much space of bits and bytes to store these numbers, but for our intents and purposes, it won't make much difference. Okay, but float is more of a real number. It's a decimal value. Integer is just a non-decimal, but it can get negative. So we can do operations with both integers and floats. We can add, subtract, multiply, divide. Essentially, we have two different kinds of division. This is regular division, like 9 divided by 3. Okay, or if you do 9 and then you go // like divided by 4, that's going to give you the greatest integer. So that's going to be 9 divided by 4 is going to be 2, would be like 9 divided by 4 would be like 2 point something, 2.1 or something. But that, if you have a // it's just going to give you 2. So it's just going to give you the integer of the division. So that's kind of cool. That's a new operation you haven't seen before. Exponentiation we do with a ***. Sometimes you'll see a caret or a little hat for exponentiation, but in Python we use ***. And then finally, the remainder, the modulo function, is that percent function. So like 8 modulo 3 would be 2, right? 2, no, so 8 divided by 3 is going to be 2, remainder 2. So yeah, it would be 2. Okay, going on. So once you go ahead and open up a window in Code Sculptor and type all of these in here and see what the difference is. So these are just different. These are dividing two floats and check out what answer you get. These are dividing integers, and this is the double divide, which is going to give you like the integer value, not as opposed to the remainder, which you get with modulo. So play around with these, see what results you get, and get a sense of what's going on there. All right, coming back. All right, so for now, you're going to start playing around with some exercises. So we've created a whole bunch of exercises for you. Ideally, you print them out and do them with pencil and paper. Okay, I want you to write things down because the act of writing is going to help you remember. And you're going to try to anticipate what answer is going to be, and then you're going to go to Code Sculptor, type in the expressions, and see if your answers are correct. So the expressions looks like this. Again, you want to do this on pencil paper. So it says print 12 divided by 3. And with my pencil, I would write, that's going to have an answer of 4. And then I'm going to go to Code Sculptor, and I'm going to go print 12 divided by 3. And then I go run, and I see what I get. Aha, 4. So I was correct. And then the next one was, uh-oh, where was I? I think I'm right here. No, I was here. Yeah. So next, let's try this one. 12.0 divided by 3.0. Let's go back to Code Sculptor. Print 12.0 divided by 3.0. And then hit play. And you get 4.0. So this is the difference between dividing integers and dividing floats. So play around, plug those numbers in, and see what kind of responses you get. Okay, so that's your expressions homework. All right. I'm going to keep going. Knowing that you aren't going to really continue, come back to this video when you've done all of the exercises with expressions. Okay. Next, variables. So a variable is a way that Python can store data, and we use variables in Scratch as well, and they're very similar here in Python. So you could have a variable x equals 10, then you could do an operation x equals x plus 1. And so now your new value for x, and one thing to think about x equals, think of it as x gets equal to 10. In other words, we're assigning the value 10 to x. So now we're assigning the value of 10 plus 1 to x. And so I get x equals 11. And we can do something very similar with strings. So if x equals basket, then we can say x equals x plus ball, or basket plus ball. And we combine those two and we get basketball. So there's cool little operations with strings you can do, not just like with numbers. Variables should have specific names. So things like x and y can make it confusing. So we want to have clever names that help us to understand what our different values or objects represent. So you can have a sequence of letters. You can't start with a number for a variable, but you can have letters and numbers and underscores. They are case sensitive. So if you have, little l last little name, that would totally be different than capital L, capital N. So case sensitive. Single equals is used for assignment to variables. Double equals will test for equality. So in other words, last name equals Curry. That's an assignment. I'm setting Curry, the variable last name is equal to Curry. Average points, I'm setting that equal to 31.2. And then I ask if last name and equals equals. That's a way of saying if this variable is equal to Curry, then do this. Okay, so this equals is a testing type of equals as opposed to an assignment type of equals. So you got to keep those straight. Okay, so again, thoughtfully name your variables. You are not going to be the only one trying to read your code. You're going to have people helping you because you get stuck and you need them to be able to follow what you're doing. So be thoughtful about how you name things. So for example, if you want to find the area of a circle, I could write this code right here. I could say A equals 3.14159. Hopefully you recognize that that's pi. B is equal to 11.2. And then C is going to be my area. So C is going to be A times B times, this A times B squared. Okay, so there's my area, right? So by writing these letters in here, yes, I could get a response, but it doesn't make a lot of sense to me. And so if I make a mistake, I might not realize it. Now, if I wrote the same type of operation over here, instead of calling A equals 3.14, I call pi equals 3.14159. And I call the diameter is 11.2. And then I write area equals pi times the diameter squared. Okay? So these will accomplish the exact same things. But by naming my variables, they're going to make a lot more sense. Now, both codes contain the same error, but which one is easier to find? Hopefully you remember from geometry that the area is not pi times the diameter squared. it's pi times the radius squared. So you'd have to have diameter divided by 2 squared. Now, you might not realize that by looking at this code, but here it becomes much more obvious. So again, good reasons to thoughtfully name your code. So these are acceptable variable names, and these are not. Okay, so get used to those and come up with good. You don't want to have operators as part of your code. Underscores are okay. We have some shortcuts that we can use because we're doing a lot of iterating. You know, we're constantly adding 1 to have a counter or something. So you can use plus equals to say, so if you do x plus equals 5, that's the same as saying x equals x plus 5. X minus equals, that's saying x is equal to x minus 5. And all of these work the same way. These are the ones we use most commonly. So that's kind of nice. There's a little shortcut there. Okay, finally, now you're going to do some little exercises on variables. So again, get the printed page, fill it out with pencil and paper. If I click on here, you can take a look at the exercises. Okay, you're going to be looking at code, and you're going to try to come up with the output that will be generated if you were to run that code. So if I ran this code, what am I going to be looking at? So go ahead and write it down with a pencil, and then go to Code Sculptor and type it in and verify that you're going to get what you think you're going to get. Okay, so lots of different exercises here. Okay, actually, it's most of the same notes that you've already seen. Good. Back to here. And then finally, once you've finished the exercises for both the variables and the expressions, you are now ready for the lab. Okay, again, this is a printed page lab. Print out the lab. All of these are saved in your course calendar, and start working on variables expressions. And your task by the end of the week is to finish all of the exercises, both for expressions and variables, and then the lab to wrap it up. Okay, and a summary of the notes of this PowerPoint are concluded right here, and I've linked to this as well, so you can bring that up and print it out or keep it in a binder or just know that it's there. Okay, and that concludes this lecture.